this video, we're going to talk about another SAT Subject Math 2's advanced problem about the quadratic function. Question of our question will be solve. You'll be solve for a division between the zeros of the quadratic function y is equal to 2x squared plus x minus 6. And as we can see through our function y is equal to 2x squared plus 6 plus x minus 6, obviously we can see that this question is basically all about the quadratic function system. So there are 4 types of choice that we can make as we solve this problem. And in order to solve for this problem, we have 3 things that we need to know in order to approach this question. The first thing will be definition and types of quadratic function and its graphs. The quadratic function that we're going to basically talk about is the most important thing in the quadratic function will be quadratic. And we might think about the quadratic function from its basic format, which will going to be y is equal to ax squared plus bx plus c. And as we can see, y is equal to ax plus bx plus c will be the most basic format of our quadratic function system, which we call it as the standard form of our quadratic function. And the y is equal to a squared plus bx is a standard form of our quadratic function. So this is the first thing, and this is the main thing that we're going to use when it comes to solving these kind of quadratic function problems. And another most important things when it comes to solving this problem is what does its constants or variables affects in our quadratic function. Well, the first thing that we might talk about when it comes to talking about its variables will be what is the y? What is the y? And the y value, or we usually notate it as the f of x2, y or f of x will be in specific output of our quadratic function. Y or f of x will be a specific output of our quadratic function. And where can we get an output? We need to have some specific thing that we gotta generate the output. We notate it as the x value. And our x value will be input, the input x value of our quadratic function will be a specific input of our quadratic function where we input some specific values. And the reason why the input and the output are 1x is the most important thing in our quadratic function system is because we know that we notate our y value as the f and x value as x. If we add this together, we're going to get an f of x. And what is the f of x? F of x is our function. That's why the x over f is the most important thing when it comes to solving this kind of quadratic function system, f of x. And right now, we talked about the most important thing that generates the actual function. And the only thing that makes the difference between the functions will be its variables or the constants that it contains. So the next thing we might talk about is what is the a value? What is the a value for x squared term? Well, it is a leading coefficient. We call the a value as the leading coefficient. As the leading coefficient of our quadratic function system. Well, we know what is the coefficient in our quadratic function. We know what is coefficient. Coefficient will be a number. It is a number. The coefficient's definition is a number beside variables. And we obviously know what variables are. Variables are the numbers, or even we can count it as the shapes of numbers that never changes. And the most important or the basic format or example of variables will be x value or y values, because the changes or varies depends on times in our quadratic function system. So The difference between the coefficient and the leading coefficient will be defined by the term leading. The reason is because the leading term is a short term that refers to the x squared. And what is the x squared? X squared is the highest power term. It is the highest degree term in our quadratic function system. So the x squared, which we call it as the highest degree terms. So the highest degree terms coefficient, which will going to be our leading coefficient. Our leading coefficient will be our a value. And people always say that our a value is the most important thing that we need to learn in our quadratic function. The reason is because we know that the most crucial thing in our quadratic function will be the vertex. Vertex, because it is a thing that defines our types of graphs and our vertex, and it will all gonna be defined by our leading coefficient a. After we talk about the rest of the variables or constant in our quadratic function, let's think about what exactly types of vertex or the graphs that our x squared defines. The second thing that we might talk about is what is the b value in front of x value. Well, b is exactly the same kind of concept with the a value, except b value is just a coefficient. B value will be just a coefficient of our x to the first power term, which is going to be b. And this b doesn't really affect our quadratic function system, and it is just one of the coefficient that is in the quadratic function. The last thing we might talk about is what is the c value without any variables. As we can see, c is a term without variables, which we notate as the constant. And as we talked about this in a lot of videos, constant is a term that is opposite with our variables, because variables are the terms that never changes or that changes or varies every time, but constant means it is a number that never changes. C value is exactly going to be our y-intercept of our quadratic function. And we might talk about the types of y-intercepts while we're talking about what does each variables define specifically. And from here we can think about a value to our c values are all constant. We know that the x and y values are the variables with changes depends on times or situation, but a, b, and c values are the constants. What is the constant again? Well, the constant is a different term, opposite term with our variables, which means constant is a term that never changes. So that's what a, b, and c exist in our quadratic function standard form. Y is equal to ax squared plus bx plus c. Now let's think about what does these variables or constant define more specifically. Right now we're going to talk about what are the types of vertex and the graphs, which is essentially going to be the most important thing in our quadratic function. As we have talked about it in the upside, we know they will be defined by our a value, our leading coefficient. Our a value is our leading coefficient, which is the coefficient of our leading highest degree power term x squared. And if we go more specifically, we can see that the types of vertex or graphs in our quadratic function will be defined by our a's signs. So people might think that, well, there can be two cases of our vertex and the graphs types. The reason is because they said they're going to define by our a's signs. What are the signs? There are two types of signs. Well, the signs, for a signs, there can be either positive value, and if you don't know what the positive values are the terms. Positive values are the terms that if we make that number as the n value, that it should always be greater than 0. It can't be 0 or less than 0. And right now, let's think about what is the negative value, which is the opposite with the positive. Well, negative is the opposite of the positive, which means it is, if we convert our numbers as the variable n, it should always be less than 0. It can't be 0, or it can't be greater than 0. So the types of vertex array graphs will be defined when the positive value and our negative value of our n, which is our going to be a's, our leading coefficient signs. So for the first type of our quadratic functions, graphs will be defined when our leading coefficient a is greater than 0. And as we can see, what is the term that is greater than 0? Well, it is the term that is positive value. The positive value. The value that is number, if it is greater than 0, it always should be a positive value. And when the a value, our leading coefficient, is greater than 0, the graph of our quadratic functions will open upward. The graph of our quadratic functions graph will open upward when our a value, our leading coefficient, is greater than 0. Now, if you think about the types of graphs when it is going upward, for example, it will look something like this. That keeps going toward upward. And if it's going toward upward, you're gonna never intersect together at one point. And then you will contain one of the most important point in our quadratic functions graph, which is right over here, which we're gonna call or notate it as the minimum. We'll notate it as the minimum or lowest point, the lowest point on our quadratic function, and this will occur when our a value is greater than 0. So the minimum and the lowest point will occur when our leading coefficient a is greater than 0, when it is positive value. So when it is positive value, the graph of a quadratic function, if you review again, it will go upward. It will go upward, never intersects at one point, but it will contain another most important point in our quadratic function, which is, it can be either minimum, or we can also call it as the lowest point on our quadratic function. So it will be when the leading coefficient, this will occur when our leading coefficient a value is greater than 0, when it is positive value. We thought about when our e value is greater than 0, when our e value was the leading coefficient. Let's think about the second case. The second case of our quadratic functions graphs. So this will gonna be a second types. The second time will be defined when our a value, which is our leading coefficient, is less than 0. When the e value is less than 0, which is exactly opposite type with our first one, where it went a less than 0. When it is less than 0, which means our a value, our leading coefficient, is a negative value. So when our a value is negative value, the graph, so when our a value is negative value, the graph of our quadratic function, and the graph of our quadratic function's graph, will opens, or we can say it goes upward. And when it goes upward, which is exactly, well, it's not upward, it should be downward. And when the quadratic function's graph goes downward, which is exactly opposite with our first one where it went upward, the graph of our quadratic function will look something like this. So if you try it again, it will look something like this, that keeps going toward downward, never intersects at one point. So let's try it again. The graph of our quadratic function where it opens up downward, it will look something like this, that keeps going toward downward, never intersects at one point. But then it will contain one most important point in our quadratic function system. Like the first one, it will be located right over here. And we usually call it, or we can say we notate this we notate this as the maximum. We notate this point as the maximum, or in other words, highest point. The highest point on our quadratic function. So if you write it more in a neat way, when it is maximum point, we can also call it as the highest point on our quadratic function. And when it goes to the highest point, the maximum or the highest point. And this will occur when our leading coefficient a value is greater than 0. So these things will occur when our a value, our leading coefficient, is greater than 0. When the a value is greater than 0. This will gonna be the second case of our quadratic functions types of graphs and a vertex. From here, we might think about what is the definition of our vertex. That is the most important thing that we are seeking for throughout the whole quadratic function system. The definition of our vertex will be the addition between the minimum point and the maximum point. The vertex will be the addition between the minimum point and the maximum point, which is essentially going to be the vertex. The vertex will be defined, or it will be controlled by our leading coefficient. Our leading coefficient, which is a coefficient of our leading term, a. This is the definition of our vertex and types of vertex, as well as the graphs in our quadratic function. And the second thing that we might talk about specifically as the second part of our things that we need to know in order to solve for this question will be, what are the types of our y-intercepts? Because we know that our c value, which is the constant, is our y-intercepts. So the second thing that we might talk about, the things that we need to know in order to solve this question will be, what is the types of the intercepts? And if we further think about it, we might think about, what is the definition of the intercepts? Well, that will be the point. There is a point on the axis. Well, people might think that, well, there will be two cases of our intercept, because we know that for the axis, there are two cases, x or y-axis. There can be either x or y-axis, which means the point can be either horizontal or the vertical axis. So there will be two cases. So the first case that we might talk about, it will be our x-intercepts. So the first thing that we might talk about is, what is the y-axis? The point is on the y-axis. What happens when the point is on the y-axis? Well, it'll be x-intercepts. It'll be the x-intercepts when our point is on the x-axis. And when the point is on the x-axis, so when the point is on the x-axis, if we convert this into a specific format of our, we can say coordinate, it will be when our x value, which we call it or notate it as our specific input of our quadratic function exists, our y value will be equal to 0. This is what the x-axis will going to be. Now let's think about what will be the second thing that we need to talk about. Well, the second thing will be when the point is on the x-axis, not a x-axis. Even though it's on the different axis, the point or the whole concept will be exactly same. It will be a y-intercepts. It will be a y-intercepts when our point is on the y-axis. Then if we convert this into some specific coordinate of our quadratic function, it will be when the x value, our input, is equal to 0, our y value, which we notate as our output, our specific function will exist, and we will notate as the y value or the f of x. These are the types of our intercepts that we need to talk about in order to solve this question. And in this case, the c value, which is the y-intercept, will be when the y-axis, which means when you convert it into a coordinate, it will be when our a value, our x value, which is the input is equal to 0, our y value, which is the output exists. And the whole reason why we notate as the x or y not as specific values because x and y are the variables, which means they changes or differs depends on times. So we can't just say that it is a specific number. It should be a specific shapes, which we call as the x or y. So these are things that we need to know in order to solve for our equation. And let's go back to our original question, and our original question will be solve for the division. So the first thing will be solve for division. Solve for division of what? Between the zeros. Now we might talk about what are the zeros. Well, the 0 is 0, but this question is not talking about that 0. Zeros of the quadratic function of y is equal to 2x squared plus x minus 6. So in this case, the zeros, as we had talked about this in few past videos, the zeros in our quadratic function will be when our y value, what is our y value? Output is equal to 0. The zeros is telling us to solve for a value when our y value is equal to 0. Well, when is the case when our y value is equal to 0? It will be our x-axis. When our x value exists, our y value should always be equal to 0. So our zeros, which we also call it as the roots, it is same thing with our x-intercepts. This is what the zeros are, and we need to know in order to solve for our question. So let's get through the actual question, what we need to do in order to solve for our equation. Well, as we can see, the most important thing when it comes to solving this question is how we're gonna solve the zeros, which is same thing with the x-intercepts. Well, there are basically 3 ways, but in our standard form. But we're trying to deal with this problem through our standard form. What is the standard format? It is the most basic format in our specific function, and that specific function will be our quadratic function. What is the standard form in our quadratic function? Y is equal to ax squared plus bx plus c. So from here, we need to think about how we're gonna solve our zeros, our x-intercepts. Well, people might think that the easiest thing for our standard form will be convert our standard form into a binomial form, as we had talked about this in a lot of videos. And what is the binomial form? Our binomial form will be different with our standard form. Y is equal to a times x minus p times x minus z. And how we're going to convert our standard form through our binomial form? Well, by the factorization. And as we can talk about this, the reason why we convert our standard form in our binomial form is because the binomial form is maybe the easiest form to solve for our x-intercepts, which is the terms that we use to show when the y value is equal to 0. And in order to solve for it, we need to factor that terms. And what it means by factoring, it is the same thing with dividing our standard form into a binomial, the 2 nomials. Well, let's write our quadratic function down. Our quadratic function in this case was y is equal to 2x squared plus x minus 6. But as we can see, you'll be dumb if we convert this into a binomial form, which means this quadratic function is a non-factorable quadratic function, which means we can't factor this. So we can't use factorization in this quadratic function. Well, there are another way for this. It is the way to apply our formula. What is the formula? Well, the formula that we talked about a lot of videos, it is to solve for our zeros. And the formula is solve for zeros, but it is not this time, because formula is not to solve for zeros, but you'll be actually so dumb and it will take us long time if it is not factorable, if we can't apply our factorization. So a lot of mathematicians thought that how we're gonna solve for the zeros when it is non-factorable, because we can't apply our formula, we can't convert into a binomial form. So they made a specific formula, a more crucial or a most important thing in our quadratic function. The formula of our quadratic function. And what is the formula? It is to solve for our roots, our x-intercepts. And we also talked about this in a lot of videos. We call it our formula as the quadratic formula. And the reason why we call it as the quadratic formula, also we call it this as the discriminant. The reason because it is a formula that we can only apply to solve for our x-intercepts in our quadratic function. That's why the name is quadratic formula. So let's get through what is the quadratic formula in order to solve for our x-intercepts zeros. Formula for our quadratic formula will be minus b plus or minus square root of b squared minus 4ac and all of that over, which is same thing with dividing them by 2 times a. This is a formula for it. And if you want to solve or apply this formula, we need to know what are the a, b, or c. What are the a value, or b value, and our c value? Well, these values are originally from our standard form. So these values are originated from our standard form in our quadratic function system. Well, firstly, let's think about what is a in the denominator. The a value will be our leading coefficient that we talked about that defines our quadratic functions types of graphs and vertex. Leading coefficient. And secondly, let's think about what is b. Well, b is same kind of concept with the a value, which is just a coefficient, not a coefficient, but the coefficient of x to the first power. Well, the last thing that we need to talk about is what is the value c? Well, as we had talked about it, x value, the c value, is also a constant, which will going to be a y-intercept when the x value is equal to 0. Y-intercepts. So we'll just call it as y-intercepts. So these are the constants in our quadratic function. But we might think about it this way. Well, there are the quadratic function's roots. For the quadratic function's roots, so for the quadratic function's roots, and what is root again? Well, it is a term that we usually talk about when our x values exist and our y value should always be equal to 0, which will going to be our x-intercept. Think about the first case, when the function we're going to call as the f of x doesn't, okay, so we can say that when the f of x doesn't contain a root, no roots. When it is no roots, the first case about a quadratic function, let's say quadratic function's graph, if we draw it on our coordinate plane, and again the coordinate plane is a plane that is formed by the x and our y-axis, which we can call it as the vertical or horizontal axis, x or y. So from here, when it doesn't contain x value, which means it is not on the x-axis, it might look something like this, for example. So example will be something like this, or something like this that doesn't contain any roots, which is same thing with doesn't contain any x-intercepts. So let's think about these two cases. If we draw a more neat way, which will look something like this. Let's say it looks something like this. It doesn't have any roots. And there will be a second case when f of x contains roots. Well, when it contains roots, which is same thing with having a x-intercept, so which is the term that we use when our x value is equal to 0, not equal to 0. Then again, the graphs will be plotted on our coordinate plane. The same thing here, x and the y-axis, which is vertical, and the horizontal axis. Firstly, you should pass through our x-axis, which will look something like this, for example. Well, but then if it contains a x-axis, it must have a two x-intercepts. Well, but if you think about it through our formula, where are the two intercepts? Where are the two intercepts from our formula? Negative b plus minus square root of b squared minus 4ac divided by 2a. There is no two roots. Well, that is the main point of our quadratic formula. So if you write our quadratic formula down again, so it is negative b plus or minus square root of b squared minus 4ac, all of them over 2a. So this is the quadratic formula that we have. So there are two cases. It will be defined by our plus or minus sign. This is same thing with dividing our terms. There will be minus b plus square root of b squared minus 4ac, and all of that over 2a. All of that over 2a. And another thing will be negative b minus square root of b squared minus 4ac. All of that over 2a. These are the two we can say formula, or it is a two roots that the quadratic function's graph must contain. And how did it make it into one, which is minus b plus or minus square root of b squared minus 4ac? Well, we know the difference between these two difference between these two roots will be plus and minus. All of them are same, so we shorten it by saying plus or minus, and then all of them. So if you think about the quadratic formula, there should always be two quadratic formula, minus b plus square root of b squared minus 4ac over 2a, minus b minus square root of b squared minus 4ac over 2a. These are going to be our two roots. And the only reason is because they shortened it to make it clear and simple. So let's actually apply this to our quadratic function. What is our quadratic function? Y is equal to negative b. This is not negative b, it should be y is equal to 2x squared plus x minus 6 according to the problem. So in order to apply our quadratic formula, we need to know what is a, b, and c in our quadratic function. Well, firstly, our a value, which is our leading coefficient, will be the term that is in front of our leading term x squared, positive 2. What is the b, which is just a coefficient of the x squared term, x to first power term? Well, there's nothing, which is same thing with just 1. Well, what is the c, which is our y-intercept, the constant? It will be negative 6. So these are the 3 things that we had to figure out in order to apply our quadratic formula. And again, the reason why we apply our quadratic formula is to solve for our roots. What are the roots? They are when the they're the x-intercept, which means when the x value exists, our output of our function should always be equal to 0. So let's apply our formula: minus b plus or minus square root of b squared minus 4ac, and all of that over 2a. So if you think about it, what is the b? So we put negative, and what is the b? 1. And there will be plus or a minus square root of what is b? 1 squared is just 1. Minus what is a? Our a value is 2. For negative 4 times 2, which is negative 8, and times c, which is negative 6. So it will be negative 4 times a value, which is 2, times negative 6. And all of them over in the denominator, we need to deal with our denominator, which is 2 times a. And our a value is 2 times 2. So all you have to do in order to solve for our root is simplify. If you simplify, our denominator will be 4. And in the numerator, it will be negative 1 plus or minus square root. What is negative 4 times 2 times negative 6? Well, negative 4 times 2 is negative 8 times negative 6 will be 8 times 6, which is equal to 48. So it will be negative 1 plus or a minus square root of 48, all of them over 4. This will be our root. But as we can see, we need to also count as plus or a minus. So if we write our 2 terms, the first root will be negative 1 plus square root of 48. All of them over 4. And what is our second root? Our second one is negative 1 minus square root of 48. And then all of them over our denominator 4. These are the 2 roots. These are the 2 roots that we solved for applying our quadratic formula: negative b plus or minus square root of b squared minus 4ac divided by 2a. But this is not our total question. What is our equation? Our equation will be solved for the division. Division between our 2 x-intercepts. So again, we're trying to solve the division of them. What is division? Division is a reciprocal. It's a reciprocal of our multiplication. So the division will be minus 1 plus square root of 48 divided by 4. So all of them divide by 4, which will going to be our first root, divided by this one is same thing we multiply reciprocal of them, which is 4. The denominator 4 went to the numerator 4, and all of them divided by negative 1 minus square root of 48. And if you simplify all of it, so if you simplify all of it, 4 and a 4 will turn to 1, and the 1. Negative 1 and the negative 1 will turn to 1, the 1. Positive 48 divided by negative 48 will be 1, and the negative 1. So it will be negative, so it will be negative 1 over 1, which is essentially going to be negative 1. So our negative 1 will be our multiplication between the roots. So if we go back to our own choices, A is negative 2 is not, 65, B is not, C is not, D is not. So our answer will be none of them.